All right, so let's take a look here at lesson 5. Lesson 5 has to do with transforming functions. So before we get started here, just let me clear up. All right, so to start off here, it says functions can be transformed or moved in many different ways. A transformation can do the following things. So we can translate, right, which is to shift either horizontally or vertically. So just move a function. We can scale a function, which compresses or stretches it. And then we can also reflect or flip a function over a given line or an axis. So a factor k is used to transform functions. The factor k is a positive or negative numeric value that can be added to or can multiply a function. A parent function is the most basic of functions. A parent function often represents the original function before any transformations are applied. The parent function for a linear function is f of x equals x. The slope of the linear parent function is 1, and its y-intercept is 0. So our parent function is the most basic function, right? And then to get other functions that are related to it, we either are going to translate, scale, or reflect that parent function. So this part is very important in terms of the rest of this chapter, or the rest of this lesson here. So for a linear function, f of x plus k vertically shifts the graph of f of x up when k is greater than 0, right? So a positive number, or down when k is less than 0, or a negative number. So it's just moving it up or down. When we have f of x and we have the plus k inside of these parentheses here, that's going to be a horizontal shift. So it's a horizontal shift to the left when k is positive, and then to the right when k is negative. Another thing we can do is multiply the whole function by k, so k times f of x, and that compresses the function of the graph vertically when k is between 0 and 1, right? So that means then k is like 1/2 or any sort of decimal between 0 and 1 or fraction between 0 and 1. And then it stretches the graph vertically when k is greater than 1. So if k is a positive number greater than 1, it stretches it. The key here is that the x-intercept stays the same. So when we're doing a compression or stretching, the x-intercept here stays the same when we're multiplying the function, the whole function, by k. When we're just multiplying inside here, f of k times x, it's going to stretch the graph of f of x horizontally. So this stretches it horizontally when k is between 0 and 1. And then it compresses the graph horizontally when k is greater than 1. And here, for this type of transformation here, the y-intercept stays the same. So that's something to take a look at here. And then if we multiply the whole function by -1, it reflects the function over the x-axis. And if we're just multiplying the inside here by -1 here, so f of negative x is going to reflect or flip it over the y-axis here. So some things to notice are a vertical compression pulls the graph towards the x-axis. A vertical stretching pushes the graph away from the x-axis. A horizontal stretching pushes the graph away from the y-axis, and a horizontal compression pulls the graph towards the y-axis. So when we saw those words in there, that's what they're highlighting there. All right, so going through. So again, I just copied and pasted the information from the first page here onto the second page. So if you see it here, that's where that's coming from. So on here, it says the graph of f of x is shown on the coordinate plane at right. The function g of x is f of x minus 8, represents a transformation of the graph f of x. Which statement best compares g of x and f of x? So if we're doing the whole function and then subtracting from it, we're actually looking right here at f of x plus k, because subtraction, right, can always be written as addition. So we're really adding -8 or moving it down 8 units, right? Because we're adding -8. So if we're taking a look here, g of x is going to be below f of x by 8 units. So here it says g of x is 8 units to the left of f of x, so that's not going to change, right? Because we're just going down. G of x is 8 units to the right. Nope, because when we're adding and subtracting after the f of x, we're just moving up or down. So then g of x is 8 units below f of x, which is going to be true because we're adding a negative 8. And then this last one here is not true because we moved it down. It shifted down. All right, because the negative 8 was after the f of x, it was a shift down. The next one here says the graph of f of x equals x plus 2 is transformed to create g of x as shown at right. Which equation represents g of x? So if we take a look here and see f of x, one thing we notice is that from f of x to g of x, the line started to, it became less steep, right? It starts to flatten and get closer to that x-axis. So the slope actually goes down, right? It's a different slope. If we take a look here, the y-intercept is still the same, but our x-intercept has changed. So if we're looking for the equation that represents g of x, what we're going to do is match which one of these up here matches with our thing here. And what we're doing, if we are flattening it, what we're going to do, and the y-intercept remains the same, we're actually multiplying inside of our function by a value of k. So if we're taking a look here, choice A multiplies inside by k, right? And that's where we get this function g of x. Now, if we multiply the outside by k, which is 1/2, then our x-intercept would have stayed the same. But as you can see here, we're about to intercept the x-axis here. And on the parent function or the first function, we intercepted there. So that's not true. If we were adding 1/2 or subtracting 1/2, then that line, f of x, would either shift up or down, right? And our y-intercept would have changed. So that's not true here either. So the only one that is correct keeps the y-intercept the same, which is choice A. All right. Now we're going to take a look at exponential functions. So transforming exponential functions. Exponential functions, like linear functions, can be transformed. The parent function for an exponential function is f of x equals b to the x, where b represents the base of the function. A parent function can be graphed with a transformed function on the same coordinate plane to display what transformation has occurred. The graphing function on a graphing calculator is useful for showing this. So at this time here, if you want to pause it and open up your graphing calculator, we're going to compare these two graphs and then see which one it matches with. So the two graphs that we're going to be graphing are g of x, our first f of x, which is 3 to the x. And then our second one will be g of x, which is 3 to the x plus 6. So if I flip over to my graphing calculator, and we want to do two graphs, so we'll go to graphs. So the first graph we're going to graph is the original function, which was 3, then to the x. We can hit enter. And then if we want to graph a new function, we'll hit tab. And then here, our new function will be 3 to the x, then plus 6. Oops, sorry. So see how I have that up there in the exponent? We don't want that. So then we want to bring our line back down. So we can bring back down that way. So then plus 6. And then looking at our window here, we want it to match the window that they gave us. So what we're going to do is go to menu and go to 4 window, 1 window settings. If you look here, our x minimum is going to be -2. The x maximum is 4. And then here we're counting on our scale. We're counting by, we want to do here, count by 1. Now our y minimum is going to be -10. And our y maximum, if we look at these graphs, goes all the way up to 20. So it'll be 20. And then our y scale, if we look what they counted by, between 0 and 5, right? There's 2 boxes, so they're actually counting by 2.5. So we'll do 2.5. So now if we hit OK, now we have the same exact graph that they have here. So if we're looking, the one that is the closest to the ones that we have here on our calculator is actually going to be choice D here. All right, so D. And if we take a look at our graphs here, you can see that there's a shift in the y-intercept, right? It crosses here, and then it goes up about 6, which is what we're doing here. We're just adding 6 to this graph. So our y-intercept should increase by 6, and so do the points along it there. All right. So moving on here. So question 1. Now it's your turn. So read each problem, circle the letter of the best answer. So question 1 says f of x and g of x are shown below. So f of x is a line that says equals 6x minus 3. And then g of x is 2/3 multiplied by f of x. So what we can also say here, right, g of x is also, we could say 2/3 and then substitute in f of x, 6x minus 3. So the graph of x is transformed to create the graph of g of x. What transformation is made to the graph of f of x to create the graph of g of x? So here we're multiplying the whole function by the fraction 2/3. So when we're looking at the type of transformation on that first page of notes here, it's where we're multiplying by k, right, to the whole function f of x. Then our k, 2/3, is going to be between 0 and 1. So then what that's going to do is compress the graph vertically. So we're compressing the graph vertically. And if we're taking a look here, that's going to be choice C, because we're flattening f of x. All right, we're compressing it vertically. We're making it so the slope is closer to the x-axis, right, or flattens it because we multiplied by a number between 0 and 1. All right, if we multiplied by a number greater than 1, then we would be steepening f of x. We didn't move it up or down, so it's not going to be a translation up or down because we didn't multiply the whole function by our constant there, not add or subtract it. All right, number 2 says the graph of g of x is shown below is a transformation of the parent function f of x equals 2 to the x. So f of x equals 2 to the x by a factor of k equals 3. So we need to see what happened to f of x and when our k was 3 here. So if we take a look here, first I just want to start plotting the points for f of x equals 2 to the x. So if we started the first one, if we have our table, let's say our x, and then on this side we'll have our f of x. So for the x values, we'll do 1, 0, 1, 2, 3, and 4. So when x is equal to 0, then that's 2 to the 0 power. 2 to the 0 power is 1. When x is equal to 1, that's 2 to the first power, which is 2. When x is equal to 2, that's 2 to the second power, which is 4. The next one, 2 to the third power, which is 8. And then finally, 2 to the fourth power, which is 16. So if we were to plot these on here, 0, 1 is going to be right in between here. At 1, we're up to 2. Then at 2, we go to 4. 3, we're up at 8. And 4 all the way up to 16. So this is the original function. So if we take a look here, what has happened is that our y-intercept has changed. The rate at which we're increasing did not change at all. Our y-intercept changed, and it changed by 3. If we take a look here, this y-intercept is 1, but on g of x, the y-intercept is 4, so we add 3. And we can continue this pattern here, right? So if we look at 2, our original function was at the y value 4. Our new function is up here at 7, which is just adding 3. So in order to show this, we use this f of x equals, or f of x plus whatever our number is, and our k is 3. So if we're looking at here, we're going to choice B, which shows that we just took the original function, 2 to the x, and we just added 3 to it. Just moved it up, shifted it up vertically, 3. All right, next one here. it says the graphs of f of x and g of x are shown on the coordinate plane below. So here we have these two, f of x and then g of x. The graph of g of x equals f to the x plus k. What must be the value of k? So what we want to do is, if we take a look here at the information that they gave us, they said that f of x plus k is a horizontal shift. So it shifts it to the right or to the left. So if we're going to take this f of x and shift it and somehow get it to land on this g of x, we would have to take this line here. I'll just copy this line here. Actually, let's make that a little bit thicker there. So let's go like this. So if we took this line and we wanted to move it so that it was on top of this line, we would have to shift it. Now, if we take this line and we shift it, let's see what we got here. So if we took this line and then if we're going to shift this line here, let's see why I won't let us shift it here. All right. And we want to shift it. If we shift it to the left, right, then this line is just going to move further this way, right? And it's going to be that same slope, but it's not going to be ever go on top of this g of x. But if we shift this line to the right and we just move it to the right to where our x-intercepts match, then they'll be on top of each other. So in order to move it to the right, to move a value to the right, k has to be less than 0. So we're looking at negative numbers. And to get from 0 all the way up to positive 8, we have to move negative 8. So k has to be negative 8, which is choice D. So if we're shifting this line to the right, what we're going to do is add a negative 8 inside of that original function there. All right, the next one says functions f of x and g of x are graphed on the same coordinate plane. The function g of x represents a vertical translation down of f of x. Which function can represent g of x? So when we're doing vertical shifts, right, we're adding a value after the function. And then if we're going down, it's going to be a negative number. So if we take a look at this, the only function that has adding a negative number or subtracting 10 is our last one here. The other ones all don't fit this format, so they're not shifting it vertically up or down. All right, taking a look at the last couple questions here, questions 5 and 6. Question 5 says f of x equals 0.8x. The function f of x is transformed into the function g of x, which is equal to negative 0.8x. So if we take a look here, on the front they said that if we just change the sign in front of the function, what it's going to do is reflect it over the x-axis. So describe the transformation that takes the graph f of x to the graph of g of x. So the transformation is, right, we multiply by -1 or reflected over the x-axis. So describe how the graph of exponential function f of x compares to the graph of exponential function k of f of x when k equals -1. You can just say it always reflects over the x-axis. So if we want to take a look at what number 5 looked like, right, we can go back to our calculator. Let's do a graph, go up and delete these ones here. And then we'll delete our other function. So for then this one here, we'll do 0.08 to the x, hit enter. And then if we want to see what the other one looks like, tab -0.8 to the x. Oh. So notice where they put our So here we want to have the negative in front. Oh. Or no, we were right before. Because we're taking the whole function, right? And we put our negative in front. So we have it there. Let's change our window. Let's just do zoom standard here. And what we can do is we could see, let's go on that first one. Oh, here we have 0.8. So for this one here, sorry. All right, this should be 0.8 here. All right, so if we look, right, it's just a clear reflection over the x-axis, right? So it's almost like there's a mirror on the x-axis and they're flipped over there. All right, so now number 6 here says, the function f of x is shown below. F of x equals 3x. How does f of x plus 3 compare to the graph of f of x? Well, so if f of x, then we're adding 3, that's going to be a vertical shift. So when we vertically shift something, we're not changing the steepness. All we're doing is moving it up. So I have the same slope, but the y-intercept will shift up because we're adding 3. All right, so if we want to take a look at what this looks like on the calculator, if we have f of x is 3x, right, that's going to be a straight line. And then our second one, we take whatever our f of x was, which was 3x, and then we're going to add to it 3. All we do is take this first line, right, and we're just sliding it up 3 spots on the y-intercept there. The slope stays the same. As you can see, they're parallel, and it's a vertical shift. B says, how does the graph 3 times f of x compare to the graph of f of x? So here, we're multiplying by k to the whole function. So what we're doing here is we're actually stretching the graph vertically, and the x-intercept stays the same. So we can just write that down. It stretches vertically, and the x-intercept stays the same. So if we wanted to see what that looks like, right, we'd go through. Again, our original function will stay the same as f of x, but then our second one, what we do if we're multiplying the whole thing by 3, we'll do 3, then parentheses, our original function, 3x. If we graph that there, right, we could see it still crosses the x-axis at 0, but it stretches vertically, right, and it gets a lot steeper. So it shoots up a lot faster and steeper because our 3 is a whole number, right, that is greater than 1. All right, so this is the end of these problems here. So make sure that you go through, mark down the correct answers so that for the last quiz that we give you, you can put in the answers on Schoology. If you have questions, reach out, send an email, send a text, send a message, and we'll get back to you and help you out. All right.